we can do in Java, but this is the person like working with.
The speaker slides are not on right now, so we'll sort this out and then get started.
Shall we get started?
Yeah, we're going to use the small one for now for the speakers.
Fine, fine,
Yeah.
fine. Good morning. Today is Wednesday, and welcome to CFRG session in Dublin. I'm Alexei. Next to me is Nick, and Stanislav is remote.
Hi, everyone.
Right. So I'll quickly do usual chair slides with document status and such, and then we'll get going with our agenda, which is pretty packed today. So usual, we have a minutes taker. Thank you, Taro. This session is being recorded. Note well, we follow rules similar to IETF, but this is specific IETF version of it. I hope people are aware of them. If not, please try to research. Okay. So, and as a reminder, please keep discussions professional and be nice to each other. Right. And IRTF is doing research. We have longer term view unlike IETF. And let's have a look at our agenda. So this is our agenda. Any agenda bashing? Any changes? Yes.
So like we have, or rather, I have the RSA implementation guidance document that I think is almost ready for last call. It's just like I need to add more test vectors, but I wonder if like the format is correct as of now.
Okay, thank you. So yeah, quick update on document status. We have no new RFC since we have one document, IED properties in RFC editor queue. We have one document in ISG review, and we have a couple of documents in IRSG review. Nothing is waiting on IRTF chair at the moment. Yeah, we have quite a lot of documents in flight, so please double check that the status is correct, or if not, let the chairs know after the session. We also have a few, fair amount of documents expired, and actually one of the documents that was an expired list for a very long time, I just took it out from the slides and it's actually being presented again this time. So, but this is just a reminder of things that we adopted in the research group, but not necessarily making progress on. With that, let's get to the first presentation. Jeez.
Apologies for the small text. Yeah, we can go forward. So CFRG, like any other group at the IETF or IRTF, published documents can be updated if there are errors or issues that will affect their usability. This is slightly less formalized than at the IETF, but effectively the group chairs and the IRTF chair work to take incoming erratas and mark them either as verified, in which case it's confirmed that the document needs to be changed, or hold for update, meaning it's a small enough change or editorial or non-impactful, so that if the document does get a rev, it should be incorporated, or rejected, in which case the errata is wrong. And so we went through all the open ones. There's several of them, and I'm just going to cover here each of the documents that has open erratas and what the asks are from the group, because CFRG is, as a group, is going to help us confirm these. Next slide, please. All right, so 7748, there are 3 open erratas. One was marked as rejected. Thanks, Watson Ladd from the mailing list for doing this. The first one is about a tooling change about different versions of Python. So this can hold for the next one. Would love confirmation on the list. And the errata 7824, this one involves potential updates to the test vectors. And so we'd like the authors or people who are very familiar with this document to help validate this errata. Next slide, please. All right, EDDSA. There are 4 open erratas on this, 3 of which are more notational and editorial issues. If anybody wants to confirm that is actually the case, that would be great to do. There is one that's marked that we recommend verifying, which is likely a low impact, but it's basically a greater than or equal to sign, 2 of them, where it should be a greater than or an equal to. So basically, it's code. The question here is if there's any code that has implemented this logic, and if it's possible to hit it, because there's an edge case at the value 0 or -1. The value that gets fed into this function that requires that sort of has 0 and -1 as error cases comes from a hash, so it's pretty unlikely to be 0 or 1, but these edge cases are always where bugs happen. So we'd like some help from the authors or other familiar to validate this. Next slide, please. All right, 8391, extended Merkle signature scheme, 3 erratas here, 2 marked as verify, 1 marked as hold. Although the first one is recommends a non-trivial change in the reference format, but not necessarily a security relevant change. The next 2, 6821 and 7420, I'd like someone to help me confirm for 6821 that this is correct. There's a multiplication by 2 to the power of 8, where it's claimed that it should not be that much. So there could be a size difference, whether that impacts performance or security, unclear. So this is high priority to get checked. For 7420, there is guidance required for implementers. So anybody who's implemented this, take a look at this function. I read through the document and it references a function that is not defined within the document. So if no one's run into this issue, that would be surprising, but I'd love to hear from anybody who's implemented this. Next slide. Cha-cha poly. There are 3 erratas here. There is a notation in the first one that says that a value is treated as little endian, but the test code and the test vectors treated as big endian. This is only a textual thing, but if there are implementations that have relied on this, this is also a potential concern. The next errata to verify is that there's a missing nibble in one of the test vectors. So the beginning nibble is missing. So this is something that should be verified. Third one, also recommend verify. There is a potential off by 1 error. So anybody familiar with this who's willing to take a look and evaluate whether this off by 1 error is implemented anywhere or has a security impact, that would be helpful. Next slide, please. All right, for the Leighton-McCallie hash-based signatures, thank you to Scott for reviewing these. The first one's marked as verify. The second one, the recommendation is hold because it does require some textual changes. Is that? Yeah. And any other confirmation from this, from the group who's familiar with this RFC to thumbs up on the verify would be welcome. Next slide. Okay, HPKE, this is a more recent one, but there's several erratas here, 2 of which are potentially worth verifying. I'll go over the first 3 in the middle here, which do potentially have impacts, but likely not security impacts. But the recommendation is to hold for any update of HPKE that comes. So there's clarifications recommended for several sections of the algorithms. So love confirmation from the authors on that one. For the first one, 7121, there are test vectors that have integers that the RFC requires them to be clamped, but in the test vector they are not clamped. So this is an interesting thing. I'd love to hear from the anybody who's implemented these test vectors, or the implementers of, or I guess the authors of this RFC to help validate this, because it seems like a pretty severe mismatch. For the last one, this is also recommended to verify, medium priority, which is there is underlying function that is missing some parameters that are just assumed to be implicit, maybe implicitly 0. This would really help implementers to get this right. And yeah, I'd love for the authors to help on this. And yeah, that's it for the errata. If anyone has any questions or comments about any of these, or maybe I can take a survey of the room here. Like, has anybody read through these erratas and have comments they haven't posted to the list? I'm assuming no. But we do have one person on the queue.
So one of the things that they have in RFC editor side is that they actually have an RFCs with inline errata. And my understanding is that's only happening when you have a verified errata.
That's correct. Yeah.
And one of the things, for example, you had there was, for example, the endian nesting. It's something that would actually be very useful to have in, now it's marked for the hold for the document update. But if you have it verified, then it actually would probably be, you would have a version of the RFC that actually has that fixed. Okay. So that's why I was thinking about, might be actually good idea actually think about the hold ones to see if they actually would be useful to have this kind of in place errata.
That's good feedback. So yeah, if there's anything that was recommended as hold that could be a simple change for inline verify, I'm happy to hear that feedback and change the recommendation. So like the last CFRG meeting, Anybody willing to do this? Anybody familiar with the implementations of these RFCs? And any bug hunters who want to get a new logo? Some of these erratas may be relevant. All right, thank you.
So good morning. I'd like to present the state of the CPACE draft and show you why Michel, Julia, and me think that it's now sort of a release candidate which could be ready for research group last call soon. Next slide, please. So I'd first like to give you an overview on what has changed since the last presentation at CFRG. So we now have fully included the feedback from the 3 crypto review panel reviews that we got. Essentially, the biggest change was that we, according to them, following the advice of Thomas Borna, we removed the network representation complexity from the draft, and that made things a bit less efficient, but much more concise and clearer. We have added a section on how we recommend to integrate CPACE in high-level protocols, such as TLS. And the most important aspect is that we have worked, or part of us has worked on a new paper analyzing how PEG protocols behave, PEG protocols that are analyzed in the UC framework, how they behave if there is no pre-established session ID round, which established session ID. So there's a new paper just published at Crypto this year, at Crypto Conference this year, and we have incorporated the results. We have also worked on some details. We now have both human readable and JSON test vectors for machine readable test vectors in the document. And also we added a link to the reference implementation that we used for generating the test vectors. Next slide, please. So we'd like to express a big thanks to the Crypto Panel Review members, which had very constructive and very helpful comments. And we think we have integrated all of these remarks in the draft, so that for you, for somebody who wants to review how we considered the different changes, here's the link to the file where we have tracked the individual aspects brought up and how we considered it in the updated draft. Next slide. So here's an overview on the where we boil down the insight from the recent crypto paper by Manuel, Kai, Julia, and Stas Berpek. So in a nutshell, they established that CPACE is also UC secure, even if we don't have a pre-established session ID, so that if there's no additional preceding round between the protocol partners for establishing the session key. So now we have 2 independent security analyses, one in the UC model from this year's crypto and one from in our earlier paper based on real or random game-based proof, which both established that that CPACE is secure also with the pre-established session ID. Mm-hmm. So in our opinion, this resolves the main aspect brought up by Kartik during the review. Next slide.
Sorry.
So when recapitulating what has happened since the PEG selection process. So we have been working in parallel to the draft, we have been working on scientific papers which have a one-to-one correspondence between what we are recommending in the draft and the scientific analysis. And this allowed us to focus more on the target reader group of protocol implementers, testers, and integrators, so that we have a close, detailed security analysis in the scientific paper and a more technical text written for another audience for the integrators. We gathered feedback from the list and also off the list, had some discussions with people, for instance, also René Stroik and other people, which gave us some recommendation and open questions, which cypher suites to integrate. So we asked CFRG what about, for instance, to do with decaf and Ristretto, and followed that advice and now have these 3 cypher suites integrated. We have integrated the insights of the Eaton Stabila paper and this recent paper on Bearpake in the text. We integrated the review of the crypto review panel members, added links to the reference implementation, and now think that all of the feedback that we are aware of is considered. And we think, next slide, we think that that drives us to the conclusion that the current draft is a release candidate and should be ready for the next step of research group last call. Thanks.
Okay, comments, Jonathan?
Somebody in the queue?
Somebody in the queue? Do you want to come to the mic? Remote? Okay, never mind then. Thank you very much.
Okay, cool.
Frank, do you want me to drive slides or do you want to?
Yeah, please do the slides and I'm going to tell you when to switch to the next one.
Okay, fine.
All right. Hi, everyone. This is Frank with an update on the Edges document. Next slide. So Edges is a family of authenticated encryption algorithms based on the AES1 function and optimized for CPUs with AES instructions. And this document describes 4 variants. Next. Unlike AES GCM, widely used in IETF protocols, Edges is very simple to implement correctly and efficiently. It supports large nonces up to 256 bits, allowing safe random nonces, as well as user ID encoding for multi-user security, even with 128-bit keys. High usage limits reduce pitfalls and simplify protocols. Edges also provides forward security, even if the internal state is leaked, previous data and the key remain secure. In addition, keys can be erased very early to enhance resistance against side channels and bugs related to memory safety. Next. In most real-world cases, Edges is key committing, automatically protecting against a class of attacks. It supports 128 as well as 256-bit tags for collision resistance, allowing a key to be reused without practical limits. And as specified in the draft, Edges can also function as a stream cipher or as a highly efficient MAC. It can be used as a drop-in alternative to AES-GCM in most protocols. And in addition to these useful properties, it's consistently faster than AES-GCM on common CPUs. Next. Okay, just some quick benchmarks. So Edges achieves 0.06 cycles per byte, translating to over 500 gigs per second on commodity hardware. It's also fast on mobile devices, reducing battery usage. And furthermore, a recently discovered implementation trick could further improve these results. Next slide, please. And with 256-bit keys, Edges remains faster than ASGCM with options for memory efficiency or high performance. Next. Right, so all the CPUs don't have AES instructions. And on CPUs without AES instructions, side channel attacks are a major concern for anything based on AES. Edges is easy to protect using common mitigation techniques, and it still outperforms AES-GCM in this context. That makes it a good alternative for microcontrollers as well as WebAssembly, where even with side channel protection, Edges performs really well. Next. So over the years, various people have written independent implementations in many programming languages. That includes production-ready libraries, and open source hardware designs are also available. Next. Some TLS libraries, such as Pico TLS and Facebook's TLS library, already include Edges-based cipher suite. This is not based on this document. This is based on a different draft, which specifies how to use Edges in TLS in Quick. Next. So some timeline. Edges is proven. It won the high performance category of the CESAR competition that started in 2013. And the work on a specification began 2 years later. It was accepted by CFRG and it's been presented at IETF 113 and 117. And 13 revisions were published to address all the feedback we received. Next slide, please. No breaking changes have ever been made. This is why all the security analysis made during and after the competition remains valid. And the good news is that the original security claims still hold. And a bunch of people are testing or have already deployed Edges in real-world applications. Next. These documents may be the first to align with the draft on AED properties. We have addressed all the feedback we got, including from the CFRG crypto panel review, and we believe it's now ready for the RGLC. Thanks for your attention.
Any comments, questions? Okay. All right. Thank you.
Thank you.
Mhm. Sorry. Okay, one sec.
Hello, I'm Scott Fleur, and I am, along with a bunch of others, are putting together a ML Chem security considerations draft. Next slide.
Sorry, one sec.
What this purpose of this draft is, well, ML Chem is out there, FIPS 203. What this draft is designed to do is tell basically protocol designers and protocol implementers how to use ML Chem safely. It is intended to for non-crypto savvy readers, for example, implementers of new protocols and or implementers of TLS, et cetera. To basically, it's intended to be understandable for them and to give them guidance as to how to do it safely. Nothing in this draft should be at all controversial to anybody in here. It's all should be, this is how not to do stupid stuff. And it's just here to give best practices for using ML Chem. And I forgot, I didn't put the GitHub page on here. I put it out on the mailing list. Anyone is free to contribute. Next slide. Yeah, and we put together a first cut. I think it's actually reasonable. It's on the, it's out there, but improvements can be made. There's been a couple of edits since the last one, mostly wordsmithing, typos, moving things around between sections, nothing substantive. Again, I'm sure it could be improved. Everyone is invited. Next slide. And one concern that I have personally is MLP. People will be using MLChem and protocols in lots of different ways. Replacement for Diffie-Hellman, pretty straightforward unless you're doing static. Fair enough. Public key encryption, that's going to be, people are going to use that. We probably should talk about HPKE, but quite frankly, MLChem parameter set would be nice. I don't think it should belong to this document. If someone else wants to write a draft for that, I am well for it. And for anything else that they want, bizarro things they want to do with MLChem, like authentication, to be honest, I don't know what guidance to give them. And so if anybody has some ideas around that, I would appreciate it. Next slide. Next steps, I believe there's an immediate need for MLChem. People are going to be putting it into protocols. We need to give them guidance on how to do it safely before they actually freeze it in RFCs. So I think that we want to basically push a clean, here's how to do it, a document out there quickly. I think that's the last slide.
Okay.
Okay.
We do have some people in the queue for this one. Okay. Deirdre?
Hi, Deirdre with Sandbox. Thanks for the draft. I've made a PR against it discussing binding properties. I did a little rework on that last night.
Okay.
It needs work, but I think a mention of how good MLChem is with its binding properties is probably useful because it lets you be willy-nilly in a lot of places that other chems do not allow you to be. And then I have a document for code points to use MLChem in HPKE to make it a must to use the 64-byte seed for the keys because it gives you these lovely binding properties and is basically almost equivalent to what you get with the HChem in HPKE right now. So that's floating out there. And if people are interested in just getting code points for that, I can just go ask for them. So.
Okay. I would appreciate it for code points for HPKE. Now, as for the binding properties in this draft, it's hard for me personally to say how would somebody like a implementer of Lake, how would they actually interpret that in terms of context that they understand? But I can take a look at your edits. Okay.
Daniel?
Hi, Scott. Something that's currently not in the draft, which I've held off from doing anything on, is side channels, which is a sort of open-ended amount of stuff that could be said. On the other hand, there are also major cross-cutting things like Kyber slash, which perhaps should be noted. Should I be jumping in on these and exactly what should be the cutoff point?
Okay. One of the things about this draft is I don't think we needed to be intended toward MLChem crypto creators because quite frankly, they're not likely to look at this document to understand how to implement MLChem. This is more about it advertising to the rest of the IETF saying how to use it, at least in my opinion.
Okay, thank you.
Hi, here's greeting. My suggestion is that maybe one point can be pointed out, about the failure rate. How the failure rate can be dealt with or pay attention to, either for algorithm use or maybe for protocol design.
Okay, in terms of
it could be a.
Yeah,
That's the
if
issue.
MLChem has such a low failure rate, I don't see the point in actually talking about it very much. Simply because it basically never happens in practice, even though theoretically it can.
I don't know.
Mhm.
Yeah, especially for protocol design, right?
Yeah.
Once we got the failure rate, what the protocol should do? Maybe send some notify or something. I know. Yeah, your point is the failure rate is very low.
Yeah.
Yeah. Okay.
Mhm.
Okay.
Klaus Westermann, Klaus Flair. I think with the failure rate and with all of these other things, these are going around, right? People are here's something about binding properties, here's something about failure rate, here's something about Kuiper slash. So I don't think we should give it a lot of attention, right? But because people read it somewhere, right? I think it might be helpful to very briefly address it. So there might be some value there without going overboard, of course.
Thank you, Bas. That's a good point. Yeah.
Quinn Dang Agnes, MLChem and Kuiper basically, they took they handled the failure case in the spec. So when failure happened, then it became implicit rejection. So so everything is taken care of.
Yeah.
So nothing to worry about it.
Okay. Now, Quinn, I believe there's actually two different cases of failure. One is, of course, is you have two honest parties and MLChem has extremely low but non-zero probability of having two different keys. And then there's the failure rate of, gee, someone did something in the middle and yeah. And the second case is where you have implicit rejection.
Yeah, that already taken care of in the security design of it. If you have an attacker who modified the key or modified the ciphertext, you got implicit rejection. That means the transaction would not reveal any information about the actual shared secrets or about the secret parts of the decryption key. So it took care of, they took care of both cases in the design. So it's nothing to worry about it.
Okay, yeah, there's actually text in the draft which is intended to address, to state exactly that. If that text is not adequate, please fix it.
Yeah, so yeah, just thank you for pointing out. There are two cases and they were both taken care of by the design, and non-security violation or issue would arise from those cases.
Ask one more question, one more comment. Actually, I just noticed that maybe another point is we can talk about is about the difference of the ephemeral MLKM and the fixed long-term key MLKM. So how to use them? What's the difference in different scenarios? Including like the security implementation.
I believe there's text to that tries to address that. There are basically, it says if you do ephemeral, please go do that. It's better. If you have static ephemeral, that works. It's secure. Anything else doesn't work. Don't even try.
Okay. Anyway, from my viewpoint, right, this is important for engineers.
Yes.
How to select, how to use them.
And if you don't think the text is there, expresses that adequately, again, I am free.
Okay.
Okay.
Yeah. Thank you.
All right. Thank you.
Okay.
Patrick, I don't know whether you're remote or. Patrick, no, we cannot hear you. Happy to swap with the next presentation, and then we can come back to you. Maybe you can start out your audio. Okay, all right, so we'll do that. Okay, so next BBS signature suite advanced features. Vasilis will be presenting. Okay.
Yes, hello, can you hear me?
Yes, we can.
Yeah, as the slide suggests, I will be presenting two new work items that we will ask for adoption. Those are extensions to the BPS signature scheme. That there's also standardization efforts going on with the CFRG currently. I will be presenting, but I want to give full credit to my co-editor Greg for creating this presentation first. Next slide, please. Yeah, so first of all, a little bit of background. What is BPS signatures? Well, BPS signatures are a multi-message signature protocol that supports what we call verifiable presentations, essentially proving knowledge of possession or possession of a BPS signature over a vector of messages anonymously, while optionally selectively disclosing any subset of those messages. And there is also the option to sign any message as part of that presentation as well, chosen by the. Now, we suggest two extensions here, blind signature and pseudonyms, or how the draft is called for now at least, per verifier. Let me say first of all that the BPS signatures draft is already at the CFRG. It's currently going under cryptographic panel review, and to my eyes, at least, quite stable at the moment. So to start, in this presentation, I'm going to give some motivation behind those extensions. First of all, blind signatures. Essentially, blind signatures are an extension of BPS where they allow the user to commit to some messages of their choosing. So those messages will end up signed by the issuer, but the issuer will have no idea what those messages are. And then the user will be able to create proofs and presentations normally, because what they get is just a normal signature. Pseudonyms, on the other hand, is an extension where, because as we said, the presentation that the user create of knowledge of the signature and the signed messages, those proofs are linkable. They are pseudo-random by the verifier's perspective. What this extension allows is for the verifier to have a way to link those presentations. So a pseudonym is essentially a value that is going to be constant for a specific domain and bound to a verifiable presentation. So if that domain is the verifier will be able to use this, that value to track all presentations made by a specific user targeted to that verifier. But across verifiers or across domain or for different line parties, those values will be different and there's no way to link them together. Next slide, please. So, yeah, we have the, let's say, normal three-party model as we have in the BPS signature scheme. You have a signer or an issuer that will generate the signature. We have what we call a prover in the documents. It's called a folder of the signature, or a user, or a client, and so on. Someone that holds the signature and the messages. And then a verifier that validates either the signature or the anonymous presentations made by the prover, that can be called line party, and so on. Next slide, please. So, first of all, some motivating examples for the blind signatures case. First of all, blind signatures are to be used by pseudonyms as well. So, one use case for blind signatures is for using pseudonyms. And we are going to talk about motivating examples for pseudonyms later. For blind signatures, on the other hand, another motivating example is what has been called holder binding. Essentially, binding signature to a secret key held by the holder of the signature, approver of the user, and so on, in a way that generating presentations, verifiable presentations using the signature will require access to that secret key. And this is to battle impersonation attacks or copying attacks. I have a credential, create 10 copies of it, give to all my friends, and they can use those credentials as well, like they were me. Now, this is a big topic. I don't want to go into details here because there are a lot of stuff to decide, and this is a topic that we will require also feedback by the CFRG as well. Well, depending on the curve we use, we have different assumptions for this binding. Because we are using peripheral curves, for example, in the main document, but if we want to use hardware security modules to protect that key, we need to use standard curves like P256 and so on, so we need to remove those pairings, and this is something that we also are working on to add to those documents just to allow for these higher assurance use cases. Next slide, please. So, yeah, how signatures are going, how blind signatures are going to work. Again, the user will create a commitment to the messages together with a proof of correctness of this commitment, send both of them to the issuer. The issuer will verify that the commitment is correctly formed, and generate a signature together with any message that the issuer chooses. So the final signature of messages that the user chose that are not revealed to the issuer, and messages that the user chose as well. Next, please. So, yeah, all that those writing these two documents is reuse as many things as possible from the core BPS signature draft, and if have defined as little new stuff as possible. So here, the API that we have, this is also a work in progress, is the new API we have is a blind sign operation, a verify, a blind chain operation, and a blind proof verify operation. But those are really more or less wrapper functions around the core operations from the core BPS signatures document. Next, please. Going now into pseudonyms, well, as we said, a pseudonym is a value that is meant to allow for the tracking of some verifiable presentations inside a specific domain or a specific context, but across contexts or across domains, there is not going to be any way to link presentations together. Some use cases for that is, for example, imagine that a line party will have to enforce some monetization rules for a user or some security depending on the presentations that they receive from that user. So this is something, for example, that in privacy pass they are talking about rate limiting. Those are kind of very, very closely related. So we want to allow for these kinds of use cases. Next slide, please. Now, the way pseudonym is calculated is essentially you take the codex identifier, you hash it, and then you multiply it with a pseudonym secret, and the pseudonym secret is also going to be signed by the BPS signature. Now, this secret is a random value chosen by the user or the client, and then committed to during signature generation, and only the commitment of this value will be sent to the issuer. So the issuer will have no idea about what this pseudonym secret value is, because if the issuer knew this value, they will be able to track the user specification across domains or contexts. So that's why we need the blind signatures draft for pseudonyms as well. And you will notice that for a specific context, the pseudonym value is constant, right? So that's why it can be used to track those presentations. Next slide, please. Again, same as before, try to use as many stuff from two other documents, the core document and signatures document. For pseudonym, as little stuff as possible. So we have some new APIs, the commitment with pseudonym, blind issuance with pseudonym, blind verification with pseudonym, and then proof generation and proof verification pseudonym as well. And reuse a bunch of stuff from all the other documents. Next slide, and I think that should be it. Yes, so some additional references, some presentations made to other working groups with additional materials, and some academic references, and I think that's it. I have to take questions.
Yeah, and I don't see anybody in the queue, so.
Cool. Thank you then for your attention.
Thank you.
Yeah. Can you hear me now?
Yes, we can hear you now. We'll get your slides
Right,
up
perfect.
and you can hop in.
Okay. Apparently a browser issue. All right. Thanks for the opportunity to give an overview on FrodoChem. On the screen, you can see the all the authors that contributed to the design of this crypto scheme. People from academia and industry. Next slide, please. Let me give you a brief introduction about FrodoChem. FrodoChem is a quantum-safe in CCA2 secure key encapsulation mechanism based on the harness of the plain learning with errors problem. That means that it uses generic algebraically unstructured lattices. FrodoChem was a round 3 alternate in the NIST PQC standardization process. The reason why FrodoChem was dropped from the competition was mainly due to performance. So in the NIST round 3 status report, for example, we can find a quote like this one: in terms of security, Frodo's conservative design choices are laudable. At the same time, FrodoChem has been recommended for use by several European governments and countries, including, for example, Germany, France, and Sweden. And born from this recommendation was the motivation to start a project to standardize FrodoChem with ISO. This is a project that started on April 2023. In this project, in which I'm co-editor, we have a process that is intended to standardize 3 PQC algorithms. So this is going to be the first PQC standard for ISO. This includes MLChem, Classic McLeese, and FrodoChem. We're going to have an amendment of the standard ISO IEC 18033-2. And the recent news is that just a month ago, the project was approved to move to draft amendment. Next, please. Now let me talk a little bit about the design principles of FrodoChem. The goal of the design was to achieve a simple, conservative, and practical implementation in a scheme. As I mentioned, we use plain LWE, which is intended to minimize the potential attack surface because there is no algebraic ring structure. We follow a cautious parameterization with medium-sized errors conforming to a worst-case, average-case reduction. So the theoretical framework of FrodoChem involves a series of reductions that ends with an untied reduction from worst case bounded distance decoding with discrete Gaussian samples problem to the decisional LWE problem. And using this theoretical framework is that this theoretical framework is that allow us to have relatively narrow errors, which at the same time enable smaller parameters and better efficiency for a plain LWE scheme. But I don't want to overemphasize the role of the theoretical reductions. At the end of the day, the concrete parameters are chosen according to the so-called core SVP methodology, which is similar to what other lattice-based schemes do. Basically, setting the lower bound for the first order exponential time and space complexity of the shortest vector problem to pick the parameters. Next, please. A few words about the NCCA chem transformation, similar to other schemes in the NIST competition. We begin with that NCPA public key encryption scheme. In our case, it's called Frodo PK. And using a variant of the Fujisaki Okamoto transform, we transform the public key encryption scheme to an NCCA chem scheme. And this is similar, for example, to the case of to what is done for MLChem. Next, please. So following the goals that we had for this project, for this design, being simple and having a compact implementation, well, we expect also to have simple operations that are easy to implement. In fact, the inner operations, the core operations are matrix vector products over integers modulo power of 2 modulus. So there is no use of entity or any fancy polynomial multiplication techniques, no prime modulus, and that facilitates an easier implementation. Next, please. Similar case for the error sampling. We follow an approximation to rounded Gaussian. I don't want to go into much detail that, for example, in our implementation, we use inversion sampling that simply requires very small lookup tables with some randomness. And these small tables allows to have very simple and compact implementations, and also are friendly for constant time implementation. Next. And all these, of course, ends up producing compact and simple implementations. I can give you the example of the X64 implementation that we produce that consists of only about 350 lines of plain C code plus existing symmetric primitives. This compact code actually supports all security levels for the scheme. And that really highlights the simplicity of the schemes. At the same time, the simplicity facilitates the compiler's work to produce optimized code. Again, for the case of the X64 implementation, we don't require HAN assembly code, for example. The compiler is able to translate the plain C code to vector instructions, for example, if the platform that is target supports those instructions. It's also easy to see then that this leads to implementations that are easier to secure against sidechain attacks. It has been shown, for example, that there is negligible overhead if we want to protect arithmetic operations in Photochem against first-order sidechain attacks using first-order masking. Next. Here in this slide, I show the variants and parameters that we include in our proposal. There are two options for generating the so-called public matrix A that is underlying the scheme. This matrix is produced pseudo randomly, and so for that purpose we use either AES-128 or SHADE-128. We can be chosen depending on the application or the target platform. There are also two variants depending on the reuse of public keys. One that is called standard FrodoChem, and the other one ephemeral FrodoChem. The difference is that standard FrodoChem uses a salt that is public and is included in the encapsulation process, and the purpose of this salt is to protect against certain multi-ciphertext attacks. So that allows the reuse of public keys for multiple to produce multiple ciphertexts. In total, taking all these variants and the different security levels, we have 12 parameters targeting the NIST levels 1, 3, and 5. Next. To mention a little bit about the performance profile, as expected, because this is a scheme based on plain LWE, the performance is relatively slower in comparison with something like MLChem, but still arguably practical. For example, a full execution of FrodoChem is still below 1 millisecond on a standard CPU. Encapsulation and decapsulation take around half millisecond. Public keys and ciphertexts are roughly 9, 15, and 21 kilobytes for levels 1, 3, and 5. So yeah, in terms of speed and bandwidth in comparison with MLChem, FrodoChem is slower, approximately by 1 order of magnitude, and also larger. But if we compare, for example, with another alternative that is considered conservative, like classic MacLeese, there are interesting trade-offs that we can observe. Classic MacLeese ciphertexts are small, but FrodoChem public keys are much smaller. Encapsulation and decapsulation of classic MacLeese is faster, but then if we take into account the full execution of the scheme, FrodoChem is significantly faster, more than an order of magnitude faster. Next. If we look at the security profile regarding the underlying LWE problem, we can also observe how we pick the parameters following a conservative approach. If we see in the first table on the top, we see estimates for the quantum security based on core SVP harness, and compared with MLChem, FrodoChem was chosen to have significantly larger margins of security. And the same in the second table on the bottom, that it applies for the case of classical security estimates, in this case in terms of gates and memory. Next. And to give a summary of what I have been describing so far, yeah, FrodoChem is relatively slower and takes more bandwidth in comparison with a structure lattice scheme like MLChem, but arguably practical for many applications. And I show that it shows very attractive trade-offs in comparison with other conservative schemes like classic MacLeese. So FrodoChem is conservative, achieve a conservative LWE security. The parameters that are proposed offer larger classical and quantum security margins against known attacks for the underlying LWE problem. And at the same time, all these design decisions give us a simple, compact, and easier to protect implementation. So we argue that FrodoChem is a great alternative for security-sensitive applications, and I hope I convince you of that. Next one. And so we have a proposal for a draft. It's still not public yet, but we believe it's in good shape. It's aligned with the upcoming ISO standard amendment, but we believe that can be improved further with the help of the CFRG community. We are a bunch of collaborators, including Joe Pavot from NXP, Stefan Ellen from BSI, myself from Microsoft, and Douglas Estevila from Friends University of Waterloo. next. And with that, with this, I conclude. You can find more information in that link, and also our official implementation is in GitHub repository. Thank you. And if you have any questions.
Yeah, there is a queue.
Okay.
Yeah,
Scott?
Scott Fleur, Cisco Systems. Will the draft be in sufficient detail to implement ProtoChem directly without reference to anything else?
The sound is it feels very far, but if I understand correctly, you are asking if the draft is going to be well detailed enough to to allow you to implement the scheme.
That is correct. That is.
Okay. Yes, I believe that's true.
Okay. Thank you.
Hi, John Mattsson, Ericsson. There was some discussion there has been discussion in some IETF groups about ProtoChem. If IETF protocols want to use ProtoChem, I think they should not refer to the paywalled ISO standards, but then to a CFRG draft or just to the website. I think ISO forbids discussion what's happening in ISO. I think that's completely goes against everything that internet community stands for. Secondly, when we looked a bit at ProtoChem internally at Ericsson, our conclusion was that like MLChem plus bike or MLChem plus HQC hybrids would have better performance than ProtoChem, and according to my personal view, also be more conservative in the sense that attack affecting both lattice and code-based would be less likely. Do you have any reasons why I would use ProtoChem instead of MLChem hybrids with code-based?
Oh, well, I haven't thought about that scenario in particular. Yeah, no. I would have to observe, for example, the performance profile and all those details. We have been more focused on, for example, comparing with classic MacLeese, that is the conservative alternative from the code base side. And in that case, there are good advantages in favor of ProtoChem.
Maybe can take.
Yeah. By the way, regarding your first comment, it was always the purpose of the group, the team, the ProtoChem team, to want to have an open standard, and so we always had in mind to, end up, talking to the IETF to have this done.
Yeah, good to hear.
Hi. So here is Guilin Wang from Huawei International. So you may know, actually, we have a proposal in IPsec, to use FreeDOR for IKEV to key exchange, hybrid key exchange. This person. Second one is I would like to check you. It's very good, to get your talk here so that the wider audience in IETF can know FreeDOR well. Yeah. So my question is that do you have any plan like to have a draft in IETF to introduce FreeDOR, just like Scott did, for MLK?
Sorry, I missed completely after you said if I have any plans for something, but it was too far to hear.
Speak louder. I mean, we have a proposal, a draft, to use FreeDOR for IKEV.
Yeah, that I got. So I'd be interested in getting that information. If you can share it offline, that'd be great to take a look. But regarding the last part, I didn't hear.
Second one is that do you have a plan to write a draft in CFRG or any other group to introduce FreeDOR KVM?
Oh yeah. So what I mentioned, I think, in the previous slide was that we already have a draft that we believe is in decent shape, that we want to make public. So that would be the next thing to do, to make it public and then get the feedback from the CFRG community to polish it and get it get it
Okay.
in shape. Yeah.
That's
In
great.
final shape.
So the draft is for ISO. Okay. Anyway, yeah.
Yeah, no. This could be like what I mentioned is that it could be in sync with the ISO standard, right? Because that could be the part of the plan to have, you know, um, consistency between the standards.
All right, Leif Johansson. So a quick question. You mentioned in your introduction that you had received support from the couple of governments, including the Swedish government. I'm curious who or what part that involved on the Swedish side.
Yeah, probably Stefan, if he's in the call, probably he can jump in and mention. Is the I don't remember the it's the intelligence service from the Swedish government, NSSA, if I'm not wrong about it.
Okay. No, I don't think there is such a thing.
No, so probably I'm misspelling the name of the agency.
Oh, yeah.
But
I mean, you were clear about the German side. I'm just would like to chase this down internally.
yeah, so we have a co-editor that is from BSI, Stefan Ellen, and I thought was in the call here, but yeah.
Okay.
He's also involved.
Chris Katkowski, Baker Shield. Can you confirm that the ISO version of Frodo will have this parameterization with AES? Is that the plan?
If it is the same, or
that AES parameterization will be there, or so
yes, so it's going to be both the two variants that I mentioned, supporting AES 120A and also Shake 120A. Yeah, both of them.
And can you collaborate a bit more on why it is more or easier to do SCI, the side channel security?
Yeah, sure. So briefly, just to mention is, for example, we first of all we have a matrix vector operations, and those are over the integers modulo a power of 2. So applying masking to those kind of operations is pretty straightforward. In some implementations can be even free. We have been working on a hardware implementation where basically the masking is for free, and it is completely straightforward. The other part is that the tables that we use, for example, for inversion sampling, are very small and with relatively small values. So performing table lookups is simpler and easier to do in constant time. Also, well, I can continue, but encoding, decoding, everything related, it's also much simpler than whatever is out there for structured lattices, for example.
Thank you.
Yes.
Hi, Ben Salter, UK NCSC. I'm very much not a Frodo expert, so apologies if I'm kind of a bit wrong here. But you're including 12 Frodo variants, which in my mind is quite a lot, and it includes the E Frodo variants, the ephemeral ones. Now, my understanding of those was that that was essentially an old version of Frodo that was vulnerable to this kind of multi-target attack, and the new version isn't vulnerable. So are there any benefits to including it if it's just a worse version of Frodo?
Benefits in the sense of yeah, the variants that are non-ephemeral, or the salted version is you know, as you mentioned, protected against these multi-ciphertext attacks. Now, we'd be open to discussing about the necessity of standardizing all of those variants. So all these variants are the ones that we propose, but we are open to discuss. Okay, probably, you know, certain variant is not, you know, necessary or not that useful, for example. Yeah, that could be argued. For example, also the difference between using AES 120A and Shake 120A. Really, that's a tricky thing, because depending on the platform, one is more efficient than the other one, and also there is possible acceleration that is coming for Shake 128 and those kind of details. But it could be argued that with the purpose of simplicity, maybe some parameters are not included. So yeah, we're open to that discussion.
Okay.
At least I am personally.
Thanks, Patrick.
Yeah, thank you.
Yuto. Just let me know when to change slides.
Okay, good morning, everyone. My name is Yuto Nakano from KDDI Japan. I would like to...
A little closer, please. A little closer to
Oh, okay. So I would like to share the update of the encryption algorithm RockIS. So next slide, please. Before going into the detail of the update, first I would like to briefly describe the algorithm itself. So RockIS is the authenticated encryption, like the Aegis that presented before, and it's based on sponge construction, and it uses 256-bit key for the encryption, and it generates 256-bit message authentication tag. And we evaluate the security in non-respecting settings, and in classical setting, it can provide 256-bit security against key recovery and 192-bit security against forgery. And the internet draft is available on Data Tracker, and also the academic paper is presented at ESORIX 2023. Next, please. The first update is regarding open source implementation. So I made the presentation first in IETF 115 and then 116, and since then there are some open source are published, like OpenSSL Quick TLS, and these implementations are available at the GitHub. So if you are interested in, please have a look. Okay, next, please. The next update is about the performance evaluation. So this evaluation is performed using the OpenSSL speed command and compare the performance of RockIS and Aegis 256 and also the AS 256 GCM. And on all environment, RockIS was the fastest, and also during the weekend hackathon, I did the project for the performance evaluation on mobile phone, and RockIS achieved 102 gigabits per second on Apple A18 Pro chipset. And this will be very important since the target data rate for the next generation of the mobile communication is 100. So it's important to achieve that benchmark on the encryption algorithm. Okay, next, please. Yeah, so we believe high throughput is very important because of the several use cases. The first is the high performance wide area network, which was discussed on Monday, both session, and they are considering the massive data transmission between the data centers. And so maybe the high throughput encryption is the good use case for this scenario. And also there are several discussions in 3GPP for the 6G services. And one of them is the immersive communication, which requires very high throughput communications. And there are also many 6G white papers from various organizations, and main use cases are like holography, digital twin, or big data analytics. And also other use cases, maybe massive IoT or drone platform, inter-GPU communications for like GPU clusters, and also the medical use cases as well. Okay, next, please. So in this presentation, I would like to discuss if I can get enough support for the adoption. And next, the last slide is just acknowledgement. That's all. Thank you very much.
Okay, thank you. We don't discuss the adoption here, but we're happy to take comments, and if it gets to that point, bring it to the list.
Yeah, I have two questions. First question is, how much cryptanalysis has been done against Rocket S?
So third-party evaluation has been done, and also we did the self-evaluation, which is also included in the SRX paper.
Okay. Okay. Next question would be, if you go back to the performance graphs, I believe that was slide 4. Yes, up you had. The Aegis paper presentation we had claimed that Aegis was faster than GCM. However, you have it here as consistently slower. I'm just wondering what's going on here.
So the presentation in Aegis, they do the parallel. So several Aegis are executed in parallel, and this is not parallel.
Okay.
Yes.
Okay, nobody else in the list, in the queue? Thank you.
Okay, thank you.
All right, we have Daniel for the next 2 presentations.
Yes, thank you. Hi. All right. So yeah, hi, I'm Daniel Huygens. I'm the editor of the Web Cryptography API since a few years. And one of the first things that I proposed for addition was the support for the CFRG curves, which is arguably rather overdue. But yeah, so there's a draft now since a while for the CFRG curves in the Web Crypto API. And yeah, here is an overview of the current implementation status. 2 of the 3 browsers, so Safari and Firefox, have shipped ED25519 in a stable release. Firefox has also shipped X25519. And Chromium has both, but still behind a feature flag, so not available yet. And then there is also a number of server-side runtimes which also implement Web Crypto, which have varying levels of support. So that's the good news, is that we're getting to hopefully soon relatively wide support of at least ED25519 and hopefully thereafter also X25519. Unfortunately, Curve448 is still not widely supported. Same story as in TLS in the browsers, pretty much for now. Hopefully that can change at some point. So the other bad news is that none of the ED25519 implementations in the browsers are the same. Each of them have some divergences, and each of the browser vendors also seem to have different opinions on where where we should be headed or how the implementation should work. So I will do my best to represent their opinions, but this is just, of course, a summary. And if I misrepresent any opinions, I do apologize in advance. So my understanding is that Chromium pretty much wants to do what their existing library does, which is Boring SSL, which is a fork of OpenSSL, which is also the library that most of the server-side runtimes use. And additionally, they would like to have a fully locked down specification in the sense of that, no optional behavior, fully specified what to do, especially for web crypto. I personally also think, this would be valuable to have, since obviously any diversions will be observable to web applications and might theoretically lead to incompatibilities. Although, to be perfectly fair, the divergences I'm discussing here are fairly unlikely to cause real world incompatibilities. But nevertheless, I think it's a worthy goal, although might be incompatible with the next two points, which is that Firefox, for example, I think I have a slide about this as well. Yeah, I'll get to that. But Firefox and Safari both have, views on how to improve the state of ED25519 beyond the RFC. We have discussed that a bit in the Web Application Security Working Group at the W3C, but obviously, the CFRG is a better venue to discuss those points, also because it would be nice for web crypto to be consistent with the IETF and IETF, in the sense of if you want to use web crypto to implement an IETF protocol, for example, it would be nice to know that the implementation that you get conforms to whatever the IETF specification asks of you, right? So diving a bit more into the specific divergences, first of all, Safari ships a randomized implementation of ED25519, presumably inspired by the deterministic signatures with noise draft here in the CFRG. Although since the implementation is not open source, I do not know for sure, which version of the draft they implement and so on. Perhaps, if there's someone from Apple who could clarify, that would be great. But yeah, it's obviously clearly observable that the signatures are not deterministic. And this, by the way, is not only true for web crypto, it is true for any application that uses Apple's CryptoKit. So any application on Mac that's going to implement an IETF protocol using CryptoKit is gonna be divergent from RFC 8032. So we have an open issue in this about the spec to basically ask, well, should we allow that? My personal position is that it's not ideal to refer to draft. So I guess the most concrete open question here is, should we move this forward to an RFC to basically reflect the reality of what Safari and Apple in general has shipped. So next concrete issue is about the small order points. So there is there has been a bunch of research about this, and basically Mozilla's position is that we should reject small order points to protect against a certain class of attacks. I won't go into the full research here. I'm also not an expert on it. But yeah, so based on that, we initially added to the spec to require doing these checks and to reject small order points in keys and signatures. Although then later on, Chromium basically said that they want to do whatever boring SSL does, and they don't do the small order checks. There's an open question about should we make these optional, or should we specify it in the CFRG to do these checks so that boring SSL perhaps has a more solid ground to implement them as well. I see someone in the queue. Is it about this specific slide? If so,
Not specific slide, but generally about ED5 25519 is that we now also have NIST specification for that. How does that align with the checks that it requires?
that is a great question that I'm not sure about the answer to. I sort of assume that NIST sort of copied the CFRG homework, but I'm honestly not sure. I might be wrong.
I would be surprised if they did it completely verbatim, honestly.
Okay, I would have to double check. All right, so next point is about the verification equation. This issue is a bit, this point is a bit in the other direction, in the sense of here actually RFC 8032 allows a choice of verification equation, and the difference is observable. So this goes a bit against Chromium's wish of having a fully specified RFC, and in practice, as far as the implementations I've observed, everyone implements the unbatched verification, meaning the second one listed here. So this may be a case where perhaps the RFC is overly flexible. Should I? Yeah, is the queue about this specific slide, or you want to jump in, or should I go to the end?
It's about the small order check.
Okay, then I'll go back. Go ahead.
Yeah, so there have been a lot of security vulnerabilities, right, in other protocols than here. But it's
Sorry, I can't hear you very well. Could you speak slightly closer to the mic?
Sorry, Buzz from Cloudflare. So there have been a lot of issues with these small order points, but not in ED25519, right? It's been if you read the original paper, it was very in the design. We were then was aware of it, so there's no problem here. These checks are really superfluous, and I think it will cause a lot of extra work for nothing, right? I mean, it's annoying that we have implementations that behave differently, which is annoying, but it's not. I don't see a security issue here, so let's not complicate things.
Mic. Add the mic.
Add the mic, please.
Even I can. You said at the mic, not.
Dennis Jackson, Mozilla. So just to speak to Baz's point, there have absolutely been vulnerabilities in protocols using ED25519. Scuttlebutt is my favorite one because it had a simultaneous one in ED25519 and X25519. But just to, well, thank you. Just to state the positions of the browsers a little more clearly, on Mozilla's side, we think these checks are pretty simple and they serve a good purpose. At the same time, like if there's no energy to add them, we can understand that. We just want to document that in the spec so that it's written down for folks. Simultaneously, like with the hedged signatures, we feel much the same way. We think it's great to support Apple in doing them, although we don't want to make it mandatory. So like, I think there's maybe more alignment here than maybe represented on the slides. My understanding of what WebKit have said in public is that they're pro both the small order checks and the hedged signatures.
Yeah, agree with Dennis, Deirdre with Sandbox. In the blockchain community, there's been a lot of adoption of Ed 25519, and we had to fix a lot of these problems for distributed consensus applications. The Zcash community wrote all this down of how to do the ZIP 215 compliant Ed 25519, including we do use the batching because we verify a lot of public Ed 25519 signatures. It works great. I've implemented it. We've written it down how to do it in a consistently verifiable way. It handles the cofactors. The batching handles the cofactors. And I've put those links in the Zulip, and I can share them elsewhere about, you can literally just steal the text that we've written down in a very RFC-like way. If you want to update RFC 8032 to handle this. I know people use Ed 25519 a lot of places, and I would be very supportive to update 8032 to deal with this issue. What about Schnorr over the Ristretto group? That would be nicer, in my opinion.
So Björn, I'd like to come back to your point regarding noise in the signature. I think it's an issue that is, it's a good idea to have it integrated in some systems, not only Safari. I'd very much like to have this aspect detailed in an RFC, and I'd like to give my review and assistance to John for this deterministic signatures with noise. I think that's a point where where we should have guidance. And I don't have a strong point regarding the other issues. My opinion is that probably one could be working with the flexibility that we're currently having, as there's no security risk and there's a lot of implementation out there, also in our IoT devices, which don't implement the check and won't want to implement this check. Thanks.
Thank you. So yeah, I'll jump to my last slide, which is just very, very general questions, some of which I already mentioned. One is, yeah, should we move the randomized signatures draft towards an RFC? One is, should we write something down about the small order checks if we think that's a valuable thing to do? Obviously, there's debate about that. And then a larger point, or yeah, maybe more future point is, should we make an RFC 8032 bis to basically encapsulate all of this and sort of document what implementations are doing to reflect the reality, and also have a consistent RFC that, for example, Web Crypto and other implementations can refer to be consistent with the IETF, as I said in the beginning. So,
yeah, I think we need hedged signatures. I think we should talk about hedged signatures instead of randomized signatures to distinguish things that are hedged and just randomized, like the old ECDSA. I would be super. I resubmitted the hedge draft today. Unfortunately, it was a bit bogged down during summer, but also during spring, when we got things rolling, there was a suggestion from Bernstein, which was actually a very good suggestion to very much change quite a lot. It would be good with more group feedback, whether that's the thing to do. With the authors of the hedge draft, feels like that is the way to go, unless people have implementation and so on. But more feedback would also be great, with more help. Maybe if someone wants to step in as co-author of the hedge draft. I don't think you want to do hedge draft in the 8032 bis, then you probably get the IPR disclosure. I have nothing to do with these IPRs or the IPR disclosure, but a lot of discussion of the hedge signatures has been IPR disclosures, which might have been expired, and they're probably a prior art and so on, but that has been a lot of the discussion.
David Benjamin. Whoop. All right. Yes, we really need an 8B32 biz. I think I don't have any particular opinion on which way we go on any of these things, and if we want to do lower order checks, cool. But I just think that if we're going to grant something a name like at 2519, we had better all agree on what that even means. And if CFRG and NIST and web crypto all have slightly different at 2519s, we will end up with a mess on our hands. And particularly in sort of web space where interop is particularly important, there should be a path towards things converging in order to expose it. And I think the right way to get there is to have a biz document. So thank you for bringing this here. Hope we get a document.
David, do you have any advice with respect to the hedged document and Chrome, if you can speak to that?
So honestly, right now, most of our priorities are dealing with post-quantum rather than adding another classical algorithm to web crypto. I have no particular objection to it, but the amount of time I'm spending on this is very little. So I don't know. We should all agree on what it is. I don't care what it is.
Deirdre with Sandbox. I support Abyss very much. I think it is most important to have consistent validation and batching algorithms that handle the cofactors and the small order points. Right now, they are you can do it or not. You could do batch validation or not, and you can do it in different ways. It doesn't matter whether we make people use batch validation or not. They don't need to necessarily use batch validation. We just need to make sure that the validation for singleton and batch algorithms are the same and that they will consistently say whether a signature is valid or not if you validate it singly or you validate it with the batch. That's the most important thing in my opinion. And I think we should just multiply by the cofactor everywhere all the time, which is cheaper with batch than singleton. It will accept the most of the signatures that are out there in the world. This is what is written down in zip 215 that I just mailed to the mailing list. It is the most secure yet adaptable version of making RFC 8032 better, in my opinion.
Okay, so anything else on this presentation, Daniel, before going on to the next? What I'm hearing from the room is that there is a lot of interest in a BIS document, and there's a lot to discuss, specifically aligning with the NIST standard potentially for BIS, as well as making sure that the hedged document can also continue forward. So I think this is a good opportunity to bring this discussion to the list and see if somebody's willing to do some work on a BIS doc.
Sounds good, thank you.
And we also have some errata on the original document, so this is convenient time to fold it in. So.
All right, so on to the next web crypto topic. So there exists this very old draft in the CFRG, which is called CFRG Web Crypto Algorithms, and it's almost 10 years old. And it's about the algorithms that exist in web crypto and giving some guidance to users of the web cryptography API about which algorithms they should use, because at the time it was felt that such guidance is useful to have, but the W3C is not the right place to discuss those topics, and the CFRG is. So that's why this draft was created at the time. I emailed both of the authors listed here, and both of the emails bounced. So I believe they are no longer with the affiliations listed there. But yeah, I thought might want to discuss whether this is still something that we think is worthwhile to have. So the draft has a table in it with a bunch of algorithms from Web Crypto, although a bunch of these algorithms actually don't exist in Web Crypto today. So, you know, the table is kind of outdated, and also, of course, especially when we start adding new algorithms to Web Crypto, although hopefully we can say that people should use them, otherwise perhaps we shouldn't be adding them. But yeah, so anyway, so these algorithms actually don't exist in Web Crypto today, which, you know, possibly that's a good thing. Furthermore, you might also argue with the recommendations listed here. For example, the browsers have already started warning in the browser's developers console about the use of AES-CBC and AES-Counter on the basis that you know, they don't provide authentication, and so you know, there's arguably not a strong reason to use them today, except for legacy or compatibility reasons, of course. Yeah, the others as well, I suppose we might want to have a look and see if we still agree with the recommendations here, or if there's something that should be updated. So yeah, basically the question here is very simple. Does the group think this work is still worthwhile, and does someone want to help? So for this one, I will volunteer to, I would be happy to work on this draft, but probably it would be good to have someone else from the CFRG to help as well. If indeed we think this work is worthwhile. So yeah, let me know what you think.
I think we can do a quick survey here. Does anybody in this room think that this draft is an important thing to revive? If so, raise your hand. Small amount. And then what's the other?
Well, who's willing to help from this?
And is anybody willing to help write this document if it were to be readopted by the group? This was 10 years ago by the request of W3C that this was originally adopted. Okay, well, we can take that to list. It doesn't look like anybody's volunteering at this point.
Makes sense. All right, thanks a lot. I'll bring both topics to the list as well.
Okay, we're running a little bit early, but this is still the last presentation, and we will add a question comment period for this presentation if necessary.
Okay, great. Thanks. You can all hear me? Perfect.
We can hear you, yeah.
Okay, so I'd like to talk a bit about encodings for making MLChem public keys and ciphertext indistinguishable from random. So currently the alligator construction, which maps elliptic curve public keys to random byte strings, is ubiquitous. It's used for protocols for censorship resistance, BRFs, OPRFs, and so on. And this is all specified in RFC 9380. And so for a transition to quantum safe chem-based protocols, we'd need an equivalent construction, in particular because MLChem public keys and ciphertext are distinguishable from random. And we do have such a construction. We call this chameleon encodings. So I'll just give a high-level description of how this works. For MLChem public keys, these are vectors of polynomials with coefficients mod q. To do the encoding, we basically just accumulate this into one big number where the most significant bit is still biased towards 0. So then we do some rejection sampling based off of this bit. And notably, these encoded public keys are about 2.5% smaller than regular MLChem public keys. So this compression might be of independent interest, even aside from this randomness property. Ciphertexts are similar, except before being returned by NCAP, there's this compression property, which takes away some of the uniformity of the output distribution. So to do a similar encoding, we first have to decompress and recover the randomness loss from this compression, and then we can apply our previous technique for public keys. And then we have a few variants of these encodings. There's one that doesn't require any rejection sampling using a technique from the alligator squared work. We can also specify how to do this deterministically. Basically, how would you source your randomness in a secure way? And then we have a slightly faster variant because the original encoding requires computing with large integers. And so at the cost of a higher rejection rate, we can compute with slightly smaller integers, which gives a slightly faster implementation. So basically, we'd like to gauge any interest in us continuing to write up a specification of these encodings. Right now, there's a very rough, like not a real draft at this GitHub link. So we'd be curious to hear if there's interest in us writing this out in more detail. And if so, which variants are interesting to people, since we don't necessarily want to specify all of these different versions. That's all.
Hi, Deirdre with Sandbox. I'm very interested in this. I saw this work at, I think it was Crypto this year, and I was already planning to implement it with my version of MLChem. I am very interested and I support this.
Great, thanks.
Hi. Just a confusing point of mathematics, why you decompress the ciphertexts and then use the mod Q encoding when you could just convert the compressed ciphertext to a binary string and not have that annoying leading bit thing going on. Is there something I'm missing here?
Yeah, so basically the compression in the MLChem step does some rounding. And so the output distribution after compression is not uniform. And so we have to like recover this uniformity property of the ciphertext before compression before we can encode them.
All right, thank you very much.
Moskowitz, anything that gets me smaller sizes, I'm going to look very heavily at. As people know here, I got very, very small capacity, very, very small packets, and I'm really desperate for something that gives me something reasonable to work with. So I'm going to be pulling up your draft and looking at it and seeing if there's any way it's going to help with what I have to do in the aviation framework. Because as people here know that I've been talking for the past couple of years, I'm desperate for an answer or a solution, as maybe. Thank you for your work.
No other questions? Well, with 7 minutes left, unless there's any other questions, please come to the line, going once, going twice. Thank you all for coming. See you next time. And thanks, Stanislav, for logging in.